first question before doing the sighting is how much total heat flux is exchanged between the fluids. And so if we target to have an outlet temperature for the hot fluid, so that is for the flue gas, of 20 degrees, what is the total heat flux? So you can write with the uppercase C or with the Q with the dots, it's the same. So we want this value in watts. So in that case, it's easy. You do a heat balance. That's one application of the first principle of thermodynamics. And because we know the mass flow rate and the inlet and outlet temperature on the hot side, we'll do this heat balance on the hot side, knowing that the same heat flux that is given by the hot fluid will be received by the cold fluid. So we can calculate this heat flux, and this is equal to the mass flow rate, so on the hot side, so on the hot fluid, the flue gas, times the Cp of the hot gas, so and multiplied by the temperature difference across the heat exchanger for this hot fluid. Because we are looking for an absolute value here, the difference of temperature, we just write the absolute value in order to have something positive. So that will be the difference between the hot temperature at the inlet minus the hot temperature at the outlet. And then once you have written this, you just apply the calculation. So the mass flow rate of hot gas is given at 50 kilograms per hour. So we want SI units because we want to find watts at the end. So you divide by 3,600 to have seconds. Then the Cp of the hot gas is given at the end of your exercise. So you have properties of the gas and of the water, and we can consider that it's around 1,000 joule per kilogram Kelvin. And then the temperature variations, you can keep degrees Celsius because you look for a temperature difference and not for an absolute temperature. So then the inlet temperature here is 135 degrees, and we want to reach 20 degrees for the outlet temperature. And then you just apply, do the calculation, and you get 1,597 watts. So it's close to 1,600, but I strongly advise to keep more than 2 significative digits if you don't want to have too much errors at the end because of the approximations.